In this video, we're going to create the in-center of a triangle. We'll begin with 3 random points, or you can even use the line segment tool to create it quickly. Let's see, this will be one side of the triangle, and then we'll have another side come out here. There we go. And not trying to make any special triangle, just trying to get a random one on the screen. There we go. And just to I guess liven it up a bit, we'll create a polygon on the inside using the polygon tool. Okay. From here, what we want to do is the in-center is created from angle bisectors. So for each one of these angles, we're going to have to bisect each one. So to do that, we do have an angle bisector tool. It's under the angle tool. I'm sorry, no it's not. It's under, where is the angle bisector? Okay, in this screencast we're going to create the in-center, which represents the equal distance away from each side of the triangle. So our first step is just to create a random triangle. You could use points, but I'll use line segment tool. Just create side AB, and then we'll do side BC, and finally side AC. And just to liven it up a bit, we will use the polygon tool to color the inside, just to jazz it up a bit. There we go. That's a nice color. Okay, we're looking at triangle ABC on the screen. And in order for us to find the in-center comes from angle bisectors. And so we need to create angle bisectors for each one of these angles. And to do that, the angle bisector tool is underneath the parallel perpendicular lines. That's where we find those tools. One of those tools is angle bisector. And so let's go ahead and create those. We'll create 3 of those, one for each angle. And all you have to do is click on the 3 points that make up the angle. So that'll cut angle C. The second point is the vertex, that's the one being cut. And finally, let's see, I'm missing A. Okay, and those are angle bisectors. And you can confirm that they're bisectors by shifting the triangle a bit, moving it around. And if you look closely at the angles, they look like the left angle is the same as the right angle. So it's cut in half. You can further confirm it by measuring the angles, but we won't do that for this activity. Okay, where all those angle bisectors come together is known as the in-center. So let's go ahead and identify where the in-center is by using the intersection tool. We only need 2 of these lines to find the intersection. Doesn't matter which 2 you pick. So D is the in-center. In fact, I'm going to relabel it to in-center. I don't like the point D. So I will go to my algebra tool, click on D, right click, and rename that. I will rename that to in-center. And there we go. So that's the in-center. That's really our goal. Now, the rest of this activity, you're actually done finding the in-center. The rest of this activity is to find the shortest distance to the sides and to find that missing circle. There's a circle involved here, the in-center. In fact, our last lesson on circumcenter, the circle was circumscribed about the triangle. This time the circle is going to be on the inside of the triangle. Now, this was a little trickier because the circle doesn't go to these points here. The circle radius goes to the perpendicular distance to the side. The perpendicular distance to each one of these sides is the shortest distance to get back to the side from the center. That's our goal here. So we are going to temporarily hide our angle bisectors just by coming over here to the side here. Again, here are the lines that make up those angle bisectors, and I'm just going to click on the bubble to hide those lines. So now I just have the in-center and the triangle, which will make it a little easier to work with. Okay, and this will make it a lot easier to find those perpendicular segments too. Okay, let's tackle the first one. We want a perpendicular line that goes from the center to this base over here. So to do that, you use the perpendicular tool, perpendicular line, select the center, select the side, And there you go, done. That is a perpendicular line. Now we want the intersection of this side right here because we're interested in the distance from the incenter to that side. And so what we'll do is we'll use the intersection tool again. It's already highlighted here. Click on the perpendicular line, click on the side, and that'll give us the intersection. Don't really care about the name. Well, actually, you know what? We'll leave the name there temporarily because what I want to do now is I want to hide this perpendicular line. Control G on your keyboard does a nice job. And now I can go ahead and create the line segment. And that's the shortest distance from this incenter to the side of the triangle. We'll do the same thing 2 more times with the other sides. Actually, before I do the other sides, we have enough information here to graph the circle because all we need is the center and the point on the circumference. So let's go ahead and graph the circle, and then I think you'll see where the center is where the other ones are going to end up. Here's a circle, and there you go, right there. By clicking that point, you already are going to identify the other perpendicular line is going to go through this point over here, and the last one will go through this point down here. So let's confirm that by doing the same steps we just did. So again, we'll use the perpendicular tool, highlight the center, highlight the side of the triangle, that makes a perpendicular line, use the intersection tool to highlight the side and the perpendicular line, and that gives us that point right there. We'll go ahead and hide the perpendicular line, and we'll create the line segment, which is the radius of the circle. That's number 2. And finally, do the same thing for number 3. You'll just do the perpendicular line, do the center, and find the intersection. And finally, hide the perpendicular line and create a segment. And there we go. That is the circle inside of the triangle. It is inscribed the triangle. So now if you move, and this is what the incenter represents. The incenter, each one of these line segments is the same distance away from each side. Now it's pretty obvious that that's the case because each one of these line segments is a radius of the circle. All radii are congruent in the same circle. That's why they're all the same. So no matter what you do with the triangle, that circle will stay stuck in there. It's not going to go anywhere because it's made up of those perpendicular segments. And just to confirm they're perpendicular, let's go ahead and measure the angles. And we'll get those nice 90-degree boxes for each one of these. And one more. And we'll actually just hide those 90s, the number. Didn't want to do that. Just by right-clicking Show Label. We'll hide that 90 because the boxes tell us it's 90 degrees. Okay, so that's a nice clean picture. You know they're 90 degrees, and sure enough, if you move it around, you can see that it stays stuck. Now, don't be confused. It's very important here because students often get this confused. The goal of the incenter is to find these distances from the incenter to the side of the triangle. However, do not get confused. The incenter is created from angle bisectors. We actually need these other lines that we created originally. So let's turn these on again. This is an angle bisector. It cuts the angle in half. Same thing with the other two. The incenter is created from those angle bisector lines. Without those bisectors, we would not be able to find the incenter. Once we have the incenter, then we can find the distance to the sides using the perpendicular distance. I hope this helped.